Hi, hello everyone. Welcome to Unacademy and welcome to today's session. In this session, we are going to discuss about the data transmission modes, whether parallelly or serially it is to be done. We will see in this session. So, my dear friends, before discussing transmission modes, let us all say our anthem. Crack GATE and ESE with India's largest learning platform, none other than Unacademy. Get Plus subscription and access unlimited live and recorded lectures from India's topmost educators. So to get the top quality content from top quality educators, please be give your admission into an academy. Then an academy is going to take care of everything. So give your valuable admission, then an academy is going to perform parenting to you. About myself, Srinivasrao IS having more than 15 years of experience in the GATE. I taught in many premium academies and I also had industry experience as a data admin and a system analyst. My dear friends, many of my students completed their post graduation in IIT, NITs, and central universities. He also can perform well just by doing a good practice, proper training. So, without proper training, you cannot achieve anything. Therefore, give your valuable admission into an academy. Then we are all here to look after and see that your success. So your success comes to true real time just by cracking a competitive, prestigious competitive examination called a GATE. My dear friends, there are two kinds of subscriptions. One is 12 months and the other one 24 months. Current fourth year students can obtain 12 month subscription. And apart from top quality content, you're also going to get a maximized discount benefit. My dear friend, utilize this opportunity because the prices are going to be increased very soon. So before increasing of price hikes, immediately take the admission and get the discount benefit also. And the other kind of subscription is a 24 months. All first, second, and third and fourth year students can opt for this. So if you take the 24-month subscription, you will get recapitulation lectures like quizzes, mock test, whatnot, everything. An academy is working towards the perfect perspective of the students. So student satisfaction is an academy motto. My dear friends, please get it. Immediately join in an academy because by this month end, the prices may likely to be increased. So it is going to be much more. So that's why get a maximize the discount benefit within this month. And my referral code is eligible for all kinds of admissions which are there in an academy. My dear friends, Let's Crack Gate CSC is our YouTube channel. Subscribe our YouTube channel and use my referral code for admission into an academy to get the maximized discount. Hit the bell icon for latest notifications and updates. Now let us start our session. So when you are doing a transmission, especially physical layer I'm talking, in real-time data transmission, who could do? The application layer can able to be interfaced to the user and your physical layer is an interface to a medium. Therefore, how you can able to transmit your data through medium, either serial manner or parallel manner. My dear friends, if I'm saying that I'm transmitting the data in the form of a parallel, there is a need of n transmission lines to transmit n data bits. That means each bit is dedicated onto one transmission line. It's a costly and expensive, we know. Apart from that costly and expensive, very fast data transmission you can do with the help of parallel transmission. So my dear friends, how this is going to be done, I will show you in the picture. Whenever you see that there are two nodes would like to transmit your data, they come to an agreement that they want to transmit 8 bits. So when they want to transmit 8 bits, as I am doing a parallel transmission, there is a requirement of 8 transmission lines. So whenever there are 8 transmission lines are there, each bit is executed onto one particular line. For example, my data bits are 0100000001. Now all 8 bits are exactly set onto your lines and they are being released at a time. When they triggered at a time, then all the bits are arrived exactly at the same time. So you can able to see that very fast data transmission, especially in a parallel, no doubt. And another advantage is that bit errors are less. Why bit errors are less? Because as there are 8 lines are there, if one bit goes wrong, I don't mind. All the remaining 7 bits are being correctly arrived. Therefore, I can say that this is what is the meaning of one bit error. What is the meaning of one bit error? There may be a chance that medium failure. Whenever one line is a failure, don't worry, all the remaining bits are safely reached to the destination. So my dear friends, so we have to believe in parallel transmission, especially for transmission data between exchange to exchange and router to router and device to device, because we want to perform very fast data transmission. So that's why we believe in a parallel transmission. But only one problem, my dear friends. What is that? As you are increasing number of lines, and you are going to see what? Expansive. So mediums are going to be vast increase. So I can able to say that. What is that? As far as the definition concerned, n medium wires required to transmit n data bits. And each bit has got its own wire. And all n bits are triggered at a time and reach to the destination at a time. So apart from advantages, there are some disadvantages also there. So this is a figure how it looks like parallel transmission. There is a sender and there is a receiver. They want to trigger 8 bits. When they want to trigger 8 bits, there is a requirement of 8 physical lines. Unless and until you have 8 physical lines, you cannot work out with a parallel transmission. That's why, my dear friends, I am using 8 lines. So on the 8 lines, the bits are being triggered and bits are traversed onto the particular line. Finally, all bits are arrived at the same time at the destination side, and the receiver is going to cross check are there any errors or not. Here error is nothing but the medium line is not working fine. Then that bit is going to lost. If you look at, my dear friend, advantages is a superb speed, and one more advantage is bit errors are less. Among n lines, if you feel that there are 2 lines are lost, I don't mind, 2-bit error you are going to get. But remaining bits are going to be success. And what are the disadvantages? Very cost. Expensive. Because of expensive, because of many transmission lines, it is eligible for shorter distances. And whenever you say that multiple lines are being parallelly attached like this to your device, then there may be a chance of overlapping. That overlapping of bits from one line to other line you are going to see. Because of this overlapping, we can say the issue of a crosstalk. What is a crosstalk? When you are sending some data sequence, they may be changed because of crosstalk. That's why, my dear friends, to avoid the crosstalk, which is nothing but overlapping of the bits, and to reach to the longer distances, not to the shorter distances, and to reduce the medium cost, you're supposed to use the concept of serial transmission. What is the real-time application of your parallel transmission? You say device to device, exchange to exchange, It is a real-time example for parallel transmission. But the main issue here is that crosstalk. Whenever you are sending a sum bit, there may be overlapping each other because all the lines are parallelly available. That's why we are moving on to second variety, that is called serial. So serial means only one line is available. Even there are n data bits I want to transmit, I don't mind. I'm going to provide only one particular medium. In that medium, all n bits are going to traverse. So first bit 1 release, then bit 2 go, then bit 3 go, and bit 4 and dot dot 2. The last bit also reached from sender to the receiver. So here if you observe that, it is very inexpensive because even you are providing n data bits, I don't mind, I am going to use only one particular line. So in that line only all the data bits are being pushed one by one to others. There are a few problems. What are that? Very slow transmission. Number two, bit errors are very high. Why? If this medium got failure, then all the bits which are there on the medium are going to be lost. So that's why in serial transmission you will see that multi-burst errors. Burst errors are the real-time example for your serial transmission, and one bit error are real-time example for your parallel transmission. So bits are followed one by one, and so we need only one communication channel to transmit your data between communication devices. What is a real-time application? Computer network is a real-time application. So computer network is using the serial transmission. Okay, my dear friends. Now let us see how it is the data is being transmitted. I say I want to push 8 bits onto your medium. Then I am going to provide only one channel. So using that channel, I am going to transmit my data one by one. And this is a sender side. And this is the receiver side, how the data is being received. But they are being traversed onto your media one after another only. Because there is only one medium line between serial and parallel. But how are you going to keep in real time? Because a node to node transmission is a serial. For example, you see there is a node 1 and there is a node 2. I am providing only serial. I am working on serial. But the data which is coming to you is a parallel, no doubt, because outside whenever you do data transmission, that will be parallel only. So you are going to receive the data from others in the form of parallel. But you are trying to push your data in the form of a serial. That's why there is a requirement of converters. Parallel to serial converters required. And now this data become a what? A serial. Even though you are sending your data in the form of parallel and we are handing over to the node to serial because only one link is provided there. In general example, you speak like multiplexing, mux and demux. So multiple input lines are being compressed to a single line. While going, we want to hand over the data parallel only. So we will receive serial, but we want to hand over the data in parallel. Therefore, there is a requirement of what? Demuxing. So there is a requirement of one more converter which is trying to put your data from serial to parallel. Here I am doing a conversion from parallel to serial, and between the data transmission done by two nodes in the form of serial only. So my dear friends, the advantages of a serial transmission is that inexpensive. As it is inexpensive, I am eligible for longer distances. As there is only one channel is available, there is no crosstalk or overlapping. And these are the advantages with your serial transmission. And what is the main problem? Bit errors are more, very slower and more bit errors. So bit errors are being more. That's why we call the real-time example of the serial transmission is a burst errors. And real-time example of your parallel transmission is a 1-bit error. So 1-bit errors are the examples of your parallel transmission. You see that 1-bit errors, as many lines are lost and those many bit errors you are going to get. But in serial transmission, if a medium is lost, then you are going to see that all are bit errors only. And what are the real-time applications? Your telephone is a real-time application, satellite and microwaves, as well as your computer network. Okay, fine. So we got understood that parallel transmission is a very speed, no doubt, and the serial transmission is a very slow, no doubt. But we believe in serial transmission, especially when you are transmitting data internally, serial only we are going to use. So this serial is further divided into 3 varieties. One variety is asynchronous, and the other variety is synchronous, and the other variety is asynchronous. Okay, my dear friend, let us say how they are different each other. I will show you. First one is asynchronous. So what is the note? Since communication within the device is a parallel, this is what I am speaking, and conversion devices are required. Two conversions, parallel to serial, and serial to serial data is going from serial to parallel, conversion must be required. So here one conversion, here one conversion is required. So at the interfaces, there is a need of parallel to serial and serial to parallel conversion. Now let us see types of serial communications: asynchronous, synchronous, isochronous. Especially TV, we are going to use isochronous. Asynchronous we are going to use in ATMs, asynchronous transfer mode. In synchronous we are using telephones. Your telephone is one of the example for synchronous. Now let us see what is asynchronous first of all. So when I am talking a podcast, it is the concept of asynchronous. Now let us see what is a asynchronous transmission. Asynchronous transmission is telling you very important as far as the competitive examination concern. We will not provide any kind of synchronization statements while transmission of your data. So here timing of the signal is unimportant. We will not say that data is coming so and so time. Timing of the signal is unimportant and the synchronization of the signal is also unimportant. But how can you transmit data to the receiver, and how can your receiver is going to receive the data without any problems? Because the timing of the signal is unimportant and the sender is using a different technique to identify, that means what, to enable the receiver to identify the boundary of the frame. That's the meaning of asynchronous framing. So here let us see few important points. So I said one important, I pronounced one point. What is that? Asynchronous framing. Whenever I say that asynchronous framing, it's nothing but a pattern. The data is being transmitted to the receiver in the form of pattern only. All patterns are same. So when patterns are going to the receiver, no problem. He can able to identify boundary easily. Because the timing of the signal is unimportant, the receiver cannot able to detect the boundaries among the data bits. So these problems are identified by sender. So sender is going to put the data in the form of smaller boxes known as patterns and known as frames. And what is the maximum size of your pattern? The maximum size of your pattern is only 8 bits. Your pattern can consist not more than 8 bits. That's very important. And how this is happening, I will show you. Just to look at carefully. When I say timing of the signal is unimportant, we will not alert to the some other person that data is coming. And instead, information is received and translated agreed upon pattern. This is very important. So sender will alert to the receiver that I am sending the data in the form of small boxes. As box and box is going to the receiver, what is the problem and what is the issue at the receiver? No issues at all. Because a box consists a group of 8 bits, not more than that. So as long as patterns are coming, then there is no problem at the receiver side. He can happily identify the boundary of the frame. Why to bother? Everything pain is taken by the sender. There is no problem at the receiver. And these patterns are called as frames. And patterns are based on grouping the bit stream into a byte stream. Now let us say each pattern consists of 8 bits, not more than that. It can be a lesser, but it must not be greater than 8 bits. Very important point is it. A pattern consists of only 8 bits. So data is sent character by character, and the character consists of only 8 bits only. So data cannot be sent in more than 8-bit format. So ASCII, if you consider, I'm going to send the data in the form of 8 bits only. For example, if I'm saying I want to send a character A ASCII is a 65, so I'm going to write in the form of 011000001. So you are sending A means, so it is going to project in the form of 8 bits like this. And whenever I am saying that, and minimum and maximum, minimum must and should, one data bit must be there. And how many extra bits you are going to provide? A pattern consists of your data bits as well as overhead bits. Please understand, whenever I am saying that I am sending the data in the form of a pattern, this pattern consists of two important things. One, it consists of data bits, and the other one, it consists of overhead bits. Why overhead bits? Because I am not providing any synchronization timing signal to the receiver, so I am constructing a pattern. A pattern consists of start bit, parity bits, and stop bits. So these bits are comes under into overhead. I am sending extra bits. How many extra you can send? That depends upon the examiner wish. In general, there are 4 extra bits are there. That means total on your media you are going to send in serial medium as a asynchronous mode if you are doing 8 data bits and 4 extra bits I am sending. So when there is no data, the line is going to be under idle. So what is the process in the data transmission of asynchronous mode? We will first of all release a start bit that is nothing but a 0. Then after transmission of your data, I am sending one or more stop bits. So stop bits are nothing but ones. So there may be a chance of parity bit. And another one is that between pattern to pattern, you can also maintain a gap. So there may be a gap between each byte, nothing but one pattern. And these bits alert the receiver to the beginning and end of each byte, allow it to synchronize with the data stream. Now let me show you the figure out of this. I'm saying I want to send 2 characters or 3 characters ABC. This is the sender's wish. So 3 characters mean 3 into 8, 24 bits. So I am using serial asynchronous mode. So there is only one medium between sender and receiver. On this only we are trying to place your 3 characters, nothing but 3 bytes. So between byte to byte, you can maintain a gap. Between byte to byte, if you are interested, you can maintain a gap. A gap is nothing but some dummy characters we will send, white space characters, which are not data. So you can also do this kind of a thing. And when I am sending I want to put it in the form of a pattern. And this pattern is nothing but 8 bits of data and 4 bits of extra. What are extra, my dear friends? Start bit is a mandatory, that is usually 0. And parity bit optional, you may or you may not give. This is optional. And the last one is a very important, stop bits. So minimum 1 stop bit is required and more than 1 stop bit is also no problem. So stop bits are nothing but ones and start bits are nothing but 0. Why 0? We want to say that data is idle. So we are bringing from high to low signal. Low means always 0, high means always 1. Now after data transmission completed, we will leave to the high. High indicates a line is idle. So initially, before transmitting your A is nothing but 01000001. You want to transmit this data onto your media. First you need to send pattern. What is the pattern? I am having, first of all, start bit. And I am having parity bit. And I am also having stop bits. So all together it is called a pattern. Now send release the data in such a way. Start bit is 0 and remaining your data bits only. So I pull from high to low. That's why I kept 0. Now I am sending a data signal. 0 is the data signal. 1 is the data signal. 0 is the data and next data and next data, next data and next data, next data. After that I am using a parity. Then after that I am saying stop bits, nothing but ones. So this is a completely called as a one pattern. What is a pattern? A frame consists of start of the bit and data bits followed by parity followed by stop bits. This is a common to all the characters. So therefore, my dear friends, you want to transmit A, use a start bit and use a parity bit and use your stop bits. So this is a one pattern. And one more pattern is also there. That is for B. This is for first character. This is for second character. You can also give some kind of a gap. Now second character also same story. So start bit is required. That is 0. And your data bits. What are your data bits? B. 8 bits. Then your parity bit. Your parity bit is also there. then your stop bits is also there. All patterns are same. Now you can give a bit gap or byte gap. Now I'm transmitting C. So when you are transmitting C, same pattern is going to be constructed one more time. That is start bit and character C 8 bits and parity bit followed by your stop bits. So what I'm using? I'm using, please listen carefully. How many data bits I'm using? 8 data bits I'm using. Every character is nothing but 8 bits. And how many extra bits I'm using? The extra bits I am using, one is a start, the other one parity, and the other one or more stop bits. If I am taking one start bit, that is 0, parity bit is a even or odd 1 bit only, and your stop bits are 1 or 2. If I am taking 2 stop bits, altogether I am spending 4 extra. So in exam, he will mention how much is the overhead per each character. How much overhead for each character or for each byte. That is, out of 8 data bits, there are 4 extra according to the previous question. 4 extra out of 8 data bits. This is your overhead. If I am saying what is the link efficiency? The link efficiency is nothing but useful bits divided by total bits which are traversing on your media. So useful bits are only 8 data bits only. And how many altogether you are sending? I am sending 8 data bits plus 4 extra bits also. I am saying they are called as overhead. Therefore, my dear friends, your link efficiency in this case 8 divided by 12, which is roughly 0.66. Now listen, based on that, please observe what is the meaning of asynchronous. So very beauty, what is the beauty? Receiver do not bother anything because sender is manufactured everything. So he is sending pattern 1 and he is sending another pattern and he is sending another pattern to the receiver. As I am sending character A, B, C, they are in the form of pattern 1, nothing but frame, pattern 2 and frame 3. These are received to the receiver. What the receiver is going to do? The receiver takes those pattern 1, he will seize that. First bit is a start and last bits are stop, and he is trying to extract character A from there. So it is very easy to the receiver in order to extraction of your data bits also. So those facilities are there, especially with asynchronous data transmit. But only one problem. What is that problem? Overhead is more. As many data characters you are sending, for example, I want to maintain like this. If my bandwidth is equal to 1 Mbps, and I am saying that my overhead is equal to 4 bits for every pattern. It's fixed as far as this question concerned. Now he is asking what are actual data transfer rates? Actual data transfer rates. Nothing but he is indirectly asking throughput is asking. What is the actual throughput? Your capacity is 1 Mbps. Can you able to send 1 Mbps? No. My throughput is going to be reduced. It depends on the link efficiency into your bandwidth. So how to compute the link efficiency? Bandwidth is already mentioned, 1 Mbps. How to compute link efficiency? So here your link efficiency is nothing but useful divided by total. As I already told you, useful is 8 data bits and total I am sending 12 bits. This 12 consists of, 8 data bits and 4 extra bits. So your efficiency is 0.66 fraction. Now you apply 0.66 here. So your capacity is slightly 50% and you multiply with your bandwidth. So your throughput is reduced. My capacity is more, but I am unable to send full capacity because you are also transmitting extra bits along with you. This is the problem. This is the problem. What? With asynchronous, your throughput is going to be reduced. So this problem can be eliminated with the help of synchronous. So what is the synchronous? Synchronous concept is telephone communication is real-time example. Telephonic network. So what to do in telephonic network? Before you start communicating with others, before you conversation with others, we will not start directly conversation. First, when the phone is being lifted by other party, we will not start directly. Please understand. If you start directly, the other party may receive or may not receive properly. That's why there is a requirement of some synchronization between two parties. So he will say hello and you also will give hello. When both are sync established, then you can start transmission unlimited data. It's completely unlike your asynchronous mode. Once the sync is established between both the parties, I can transmit unlimited data characters within a single frame. A single frame consists of more number of data characters. So therefore, when you are sending huge number of data characters as a bulk in a single transmission, your overhead is less and your efficiency is increased and your throughput is increased. So I will show you how this is going to happen. First, what are you going to do? Sender will send or receiver is going to do some synchronous signals so that they are thinking that the sync is established or not. It may be one character is sufficient. If not, second time also we will say hello. Then we will start communicating each other. So first we are going to release synchronous characters to other party. Then we will start transmission of what? N data characters. But in asynchronous, we are going to transmit one pattern is equal to one character. But here, a long pattern or a long frame consists of huge number of data characters which are preceded by your sync 1 or 2 sync characters. Therefore, my dear friends, the overhead is less. For example, I am saying your data characters is equal to 1000. I don't mind, it can be n. And I say that initially I want to send sync characters. The sync characters are 2 if I am saying hello, assume. Then what is the total overhead here? Your total overhead is only 2 only because 2 characters preceded followed by n data characters. So your total characters are 1002. 1002 are your total characters. 1000 is your data and 2 is your extra. So what is your link efficiency? If you look at your link efficiency is yeah. So I will come back with your doubts. So what is the link efficiency? When you say link efficiency is your useful divided by total. So your useful is 1000 data characters I am sending divided by your total is only 1002. Therefore, your efficiency is almost all 99%. But if you look at in the previous case, what is that? Every character, observe carefully, if I am using async, every character, every one character is going to take 4 bits. If I am saying 1000 characters, then you are going to see that what is your overhead, my dear friends? Your overhead is 1000 characters, and each character is having a 4 bits extra. What are those 4 bits? One is a start bit, and one is a parity bit, and one or more stop bits. So I am taking a 4 as an assumption. So therefore, almost all you are spending 4000 bits extra. So 1000 boxes I am sending, 1000 frames I am sending, and each frame consists of 4 extra bits. But when you talk, that's what the meaning. So shorter data transmission is being done, especially in asynchronous. But in longer data transmission you need to follow synchronous. There will not be any kind of a gap. Once sync is established, they start releasing from sender to the receiver without any gap. So their overhead is less. Why? Only 2 characters I am spending out of your 1000 data characters. But here, for every data character, I am spending extra 4 bits. So my dear friends, so one of our friend is asking, when we have a large data file, then it is a time consuming. Yes, this is our first question asked by Ayush. If I am taking asynchronous, or he is talking about a serial, maybe if I am talking about the serial with asynchronous, it's very slow, I don't mind, but very slow. Okay, but 100% accuracy here. Why 100% accuracy? I am keeping everything in the form of a smaller frame, and there is no problem whatsoever at the receiver side. It's a slower only, but 100% accuracy. When you talk about you want to have a much more speed than this, then better you go a concept called synchronous. So in serial it is a bit faster because I am releasing a multiple number of characters on your media just by having a 1 or 2 sync characters. So this is the difference between asynchronous and synchronous. So our classes are begin from every day 10 p.m. my dear friends. So 10 p.m. we are going to start our classes. Please continue all these classes. Now let me do a problem here. What is the problem? Once observe asynchronous. If I am increasing data, if data is increased, then what will happen? Your overhead is also going to increase. When overhead is increased, then your link efficiency is going to be decreased because multiple extra bits are traversing onto your medium. Because of this, your throughput is also proportionately down. And if you are taking the concept of synchronous, so it doesn't mind. Even you increase your data bits, I don't mind. My overhead is fixed. My overhead is fixed because the data can be transmitted in a longer frames. So your throughput is going to be very high. So in asynchronous, we will send the data in the form of a shorter frame. In synchronous, we are going to send the data in the form of a longer frame. A frame can consist of 2 n characters, that depends upon you. So let us see a question on this. So this is one of your gate question, 2-3 times given, my dear friends. If I say bandwidth is equal to 512 Mbps, and he is saying that I am using serial transmission. So there are 2 modes he is mentioning. One is asynchronous. That means timing of the signal is unimportant. We will not say any kind of signal to the receiver. It's a self-synchronized. Whenever you say that self-synchronized, it is the concept of asynchronous only. Because a pattern itself is a synchronous, self-synchronized. And asynchronous, I am saying that 4 extra. You know what are the 4? One is a start bit, that's nothing but 0. One is a parity bit, it can be 0 or 1 based on even or parity, odd parity. The other one stop bits. So I'm taking a 2 stop bits and 1 start bit. And he is asking the second one is synchronous. It's not a self-synchronized. Sender has to make a syncing. He is using 2 sync characters and followed by 30 data characters. I can send any data characters in a longer frame data is being transmitted. Now he is asking what are the actual transfer rates? What are actual transfer rates? So your actual transfer rates are nothing but throughput only. Indirectly he is asking. We know throughput equation, the efficiency into your bandwidth. So 2 ways we have to calculate. One is for asynchronous, one is for synchronous. I'm doing first of all for asynchronous. So if you talk asynchronous, your link efficiency, please remember this formula till the computer network ending. Useful divided by total. So useful is 8 bits. Total I am sending 8 bits plus 4 extra. 8 by 12. So your efficiency is 0.66. And multiply with your bandwidth, that is a 512 Mbps. So this is your throughput, my dear friends. Almost all half. 0.66 is nothing but, you can say that nearest to 50%. So it may be 200 Mbps roughly. That is your throughput. So I'm having a 512 Mbps of channel, but because you are sending extra characters, so I'm going to give you only a roughly 210 Mbps assumption, approximately I'm saying. If you ask that what are the actual transfer rates in back character per second, character per second means byte per second. If you ask this one divided by 8, so when you divide it by 8 you are going to get bytes per second or character per second. If I am saying the synchronous, what is your link efficiency? Same, your link efficiency is the same, useful divided by total. Your useful is a 30 data characters I am sending. Please look at the questionnaire. 30 data characters I am sending with extra 2. So those 2 are not establishing a syncing. It's not a self synchronization. So totally you are sending 32. So 30 by 32, it's almost all 98%. and multiply with your bandwidth, that is a 512. It is a common in both the cases. So you get almost all 500 Mbps, my dear friends, and divided this 500 Mbps by 8, you are going to see that those many characters or bytes per second you can able to transmit. So this is the difference between synchronization and asynchronization, especially in the serial transmission. So some of our friends on the chat is asking, why can't you follow always parallel? Because we want to go for very faster. Yes, I do agree. But you can't afford that much. It is expensive. Parallel you cannot even maintain because many lines you required. How do I know that how many bits I am going to transmit? It's highly impossible. For example, if I am saying that I want to send hello, how are you? Almost all 11 characters. If I increase the sentence size before transmission of data, it is impossible to guess how many lines you need. That's why in real time, especially from one party to other party communication supposed to be in serial, I will maintain only one line. So let you do yourself parallel to serial conversion and serial to parallel conversion. Nothing but mux and demux. Hardware multiplexing. What is a multiplexing? Whenever data is coming from multiple input lines, I will streamline them into a single line. While going out, I want to distribute to parallel ways. So that serial is going to be distributed into parallel, demux. So one is a fragmentation, the other one defragmentation. Nothing but compression and decompression is happening. So that's why this is why I'm saying that serial, why we are using computer network, because inexpensive data transmission we want, but outside exchange to exchange data transmission we want to deliver data very faster. There they're going to use the parallel transmissions. Any doubts you can ask through chat, my dear friends. Please follow every computer network class. This is my third class. Last two sessions I did. Please watch them just by downloading. And now, so in asynchronous and synchronous differences we see. In synchronous, no start bits and no stop bits. Synchronization is done at a higher level using a preamble and postamble bit pattern. So your frame is going to have preamble and postamble. So whenever you talk about the serial transmission, there may be a chance of bit errors, more bit errors. But in parallel, you are going to see that only less number of bit errors. So in synchronous transmission, the bit stream is combined into longer frames, which may be multiple characters. One character is equal to 1 byte, as I said. So in synchronous transmission, we send the bits one after another without start and stop bits, no gap. But in asynchronous, we will send A followed by start, ending by stop, and you are having a bit gap also. That means byte to byte gap, frame gap. It is called as a frame gap. Then after that, I am going to start once again, start and B and stop, and again a frame gap. These are all things you're supposed to do, especially in asynchronous. But here it doesn't like. It's simply you transmit your data without stop, without start, without any frame gap. So it is the responsibility of the receiver to group the bits. Advantage is no overhead, bit faster, suitable for high-speed applications, and no clock. This is and self-synchronize. No clock signals required. Timing is not required. Byte synchronization is just accomplished in the data link layer. This is for whenever you say that timing is not required. This is asynchronous. And no clock signal is required. This is asynchronous. Self synchronize. It is asynchronous. And reminding when you are talking. Therefore, synchronous. Now the last variety is asynchronous. What is that? In real time, whenever you see that your mobile is one of the real time application of this, we are going to see that real time audio and video, in which you are going to see that odd delays. Odd delay means what? So first one object will come and followed by another object. Slowly it is going to penetrate your things onto your monitor or TV. Then you will be frustrated by seeing such kind of movies and images, because part by part it is coming. We want to see that everything has to be projected at the same time, then I can able to see a movie or image clearly. So that delay we are not going to accept. So especially gaming, whenever you are doing gaming applications, then there is a requirement of synchronous. We want to see that object has to move. Graphics, we want to see that object has to move, or everything has to be projected at the same time. So we don't want to accept this kind of uneven delays. So the uneven delays between frames are not acceptable. We want to see that everything to be projected at the same time. So that's why synchronous transmissions are being failed. For example, TV images are broadcast 30 images per second in generally. So they must be viewed at the same rate. So this is a concept called asynchronous. This you can say that you can able to use in the form of podcasting. So here what is going to happen if each image is sent by using one or more frames, and there should be no delays between frames. All frames must be attached at the same time so that we feel that the complete object is being appeared. So for this type of application, synchronization of between character is not enough. The entire stream of bits must be synchronized. So asynchronous transmission guarantees that data is arriving at a fixed rate, no floatings. So all the database must be synchronized at the same time. So this is another model of your serial transmission. So my dear friends, your web browsing, let me give you some examples here. Your web browsing, interactive applications. The interactive applications like Facebook, Instagram, and the other one, WhatsApp, for example. These are all interactive application. We want to see that reply immediately should come. We do not want to wait any delay. So in this sort of application, we want to see that data must be projected very faster. So we don't believe in asynchronous. We want to synchronize in asynchronous format. So all should be appeared at a time and all should be synchronized at a time. So in these cases, you can use the concept of asynchronous. So among the three models, my dear friends, the famous model is the famous model. So we are learning serial versus parallel. Anyhow, parallel we cannot use, that is going to be used by devices. And when you are using a serial, you decide you want a synchronous or you want asynchronous, or some of the applications are following asynchronous. So asynchronous we are using in framing concept, especially data link layer. And synchronous, I said that your telephone applications is one of the application. That's it, my dear friends. This is the difference between your parallel and serial transmission. Parallel are very faster, I agreed, but very expensive. That's why we are following a serial. In serial, some applications are based on synchronous, some applications are based on asynchronous. Asynchronous, one more example is there, that is called ATM, asynchronous transfer mode. So you can also say that framing is another example. So both are having its pros and cons. So in synchronous, receiver is responsible to arrange the cut and short frames, because the sender is keep on transmitting the data just by sending a syncing signal. So he has to cut data characters, data character, data character. Receiver is responsible there. But in asynchronous, it is not like that. As I am not sending any kind of syncing signal to the receiver, sender itself is a cut and send the frames. So receiver happily receive them because it's already available in cut and short form. So these are the differences between these three varieties. But you want effective bandwidth utilization, you prefer what? Synchronous. Your throughput is going to be very high in synchronous. Your throughput is very less in asynchronous. And overhead is very high in asynchronous, and overhead is very less in synchronous. Well, my dear friends, so we will meet in a tomorrow session, switching types. That means I will discuss in tomorrow's session circuit switching, packet switching, and message switching. And in packet switching, we learned two others, virtual circuits and datagrams. And these why we are learning? We are learning because of what? Wide area network. And it is a part of local area network. So we will discuss in tomorrow's session about these points. Stay tuned to Unacademy and stay tuned to my classes. So we will promise you that whatever subject is presenting by me on behalf of Unacademy, you will get almost all 90% marks, no doubt. 10% that depends upon your performance. But 90% you will get theoretically as well as numerically. You will be perfectly all right. But daily attendance is very, very important. Your regularity is very, very important. So you want furthermore lectures and you want in-depth training in other subjects also. Please join into Unacademy by taking my referral code. So you will get the good quality of content and you are also going to get good amount of discount. Please join, take admission into Unacademy and a good amount of discount by using my referral code. So this is my referral code. There I am going to cover few other subjects, and I already said that I am networking certified. I am networking certified, and I am also database certified, and I am also a Red Hat Linux certified. So I can give you 100% worthy. So paisa you are going to get the quality of the content. Just believe in us. Use my referral code. Get the admission into Unacademy. We will also meet there in Unacademy classes. Thank you very much, my dear friends, for your support. Please like all my videos so that I'm going to prepare much more content in upcoming computer networks classes. Computer networks is a tough subject, we all feel, but I will make it very simple with my vast experience. Thank you very much.